Welcome to your Desmos crash course video. Now, this one is going to be worth 400 points. And the reason I say that is because Desmos can be used on almost half of the math questions, so it can really help you if you, one, don't understand a concept, or two, just want to check your work on a concept that you do know. So I think this is the number one most important video on the entire series because it can earn you the most points with the least amount of effort. So make sure you're paying attention to this one and make sure you understand Desmos. The other thing I'll mention is that it's one thing to watch me do these videos and to try these problems on my own, but make sure you're doing these problems as you practice on your own. So try them in our Brainless practices. Some of them will even have Desmos links in the answer explanation, kind of showing you how you could have used Desmos. So try to use it. Practicing here will make it a lot easier and you'll understand the functions a lot better come test day. So I know we talked about this a little bit in the overview video, but there are basically two camps of calculators on the SAT. First is your handheld calculator, and these are the ones that you're probably using in math class. You charge these and bring them to the test day, and they do like addition, subtraction, multiplication, division, things of that sort. Now, the second camp is the Desmos calculator. Now, the Desmos calculator is actually provided for you on test day. So it's on the Bluebook application, it's online, and what you do is you just press the calculator button on Bluebook, it pulls up Desmos, and you can graph and do all of the different functions we'll talk about today. So like I said, really practice with Desmos, hone your skills, and it's going to be an incredible asset on the test. The use cases we are going to talk about Desmos today are going to be lines, parabolas, circles, and then other graphs. And the way we're going to go through these is basically to look at examples of these problems, and I'm going to demonstrate different Desmos functions through these problems so you have a more comprehensive understanding of what Desmos really can do. Quickly, before we move on, I'm going to talk about a few cases when you should not use Desmos. Now, I know this sounds counterintuitive, but there are a few cases where Desmos probably isn't worth your time. The first one is heavy word problems. What heavy word problems are going to test is more your ability to take a lot of words and make them mathematical equations, not really how to graph. And so in this concept, I don't think Desmos is as useful. Not to say you can't use it though. Secondly, the SAT is kind of adding more what I call theory-based questions. And these questions are kind of testing the theory behind ideas. And the reason I think they're adding these is because they know Desmos is really powerful and they want to make sure you actually understand the theory as well. And so there might be questions that don't include any numbers. They're kind of asking in like word form what a mathematical concept means. And so for questions like that, Desmos is also going to be more difficult. I wouldn't recommend it, but sometimes it might be useful. So starting with lines, the four things that Desmos is really going to help us with are x and y intercepts, finding slope, finding intersections between two lines, and transformations. So these are actually going to cover a lot of questions on the SAT, and we're going to go through a few examples here. Our first question has a system of linear equations. So here's equation number one, and here's equation number two, and it asks us what x plus y is. Now, you could do elimination or substitution on this, get the right answer, but there's a much quicker way to do this one in Desmos, which is what I'm going to show you. 2x minus y equals 7. And then our second equation is 3x plus 2y equals 14. So as you can see, this is what Desmos looks like. To enter in equations, you enter them in these little boxes on the left. And so my first equation went to this first box, and to the left side of this box here, you can see the color red, which means that whatever I graph on that box is going to result in a red equation. Under that is the same thing with blue. And as you can see on the right here on the graph side, we have both of our lines, and we actually have this little dot here where it looks like they intersect. And so all I have to do is press this dot. It tells me the intersection is at the point 4, comma 1. And then we'll go back to our question. We were looking at x plus y, so we just found out that x is 4, y is 1. So we do 4 plus 1, that's going to equal 5. So just like that, in about 30 seconds, we could have graphed that, got the right answer, and been done and been very confident in our answer. So intersections, Desmos is very, very powerful for lines, for parabolas, or for any other graph that has intersections. Now, this next question asks us which of the following systems of linear equations has no solution? Now, you could remember that no solution means same slope and different y-intercept, but if you didn't remember that, what we could do is just graph all four of these answer options and try to find the one that never intersects. So let's do that. Back in Desmos, 6x plus 4 and 3x plus 4. 6x plus 4, it says y equals 3x plus 4. Oops, plus 4. These we already see an intersection here, so that's not our answer. Next, we have y equals 8 and y equals 8x plus 5. So y equals 8, y equals 8x plus 5. These also have an intersection, so that's not our answer. Next, we have 5x plus 2 and 5x plus 4. 5x plus 2, 5x plus 4. Now, these ones I already knew weren't going to have a solution because they have the same x-intercept or same slope, but different y-intercepts. So these ones are going to be no solution, just formulaically. But we also can see in Desmos here, they never intersect. They're parallel lines, and they'll have no solution. So C here is our answer. Next, we're going to move on to parabolas. Now, the main things you can find from parabolas in Desmos are going to be intercepts, the minimum and maximum of your parabola. We'll be able to compare forms, and lastly, transformations. So here's an example question asking us what the solution to this given parabola is. So you could just factor this out, find the x's that make this 0, but much easier, we can just plug this into Desmos and see where it crosses the x-axis. So let's do that. So here in Desmos, I'm going to put in our equation, y equals x squared, and squared is just this little square button here, plus 9x minus 22. And another important note here is sometimes you have weird zoom or your graphs are really big, and so it'll look like it's not really showing up on the grid, which is what it kind of looks like here. And so you can just zoom out with this little minus button here until it looks like a parabola. Now, just like we had little circles for our intersections, Desmos also gives us these little circles where our graph crosses the x and y axes. So for the x here, I see two of them. I can click them and see that they are -11 and 2. So going back to our question, I know that x can be -11 as a solution and x can be 2. So I feel like either of these could be the right answer. And as we can see, both -11 and 2 are correct. So extremely powerful in finding XY intercepts and definitely use it because this is way quicker than just factoring. Now, this next example is a little more involved, but it's going to demonstrate an idea that's really powerful. So stay with me on this one. It says in the xy plane, a line with the equation 2y equals 20.25 intersects a parabola exactly 1 point. The parabola has equation y equals -2x squared plus kx, where k is a positive constant. What is the value of k? So I'm just going to plug in the things they give us. In this, whoops, this first equation, 2y equals 20.25. Okay, looks like a line to me. That's what we expected. This next equation is going to be a parabola. Y equals -2x squared plus kx. plus kx. Now, something's going to happen when I put this k here. Desmos is basically saying, I only get x's and y's as variables, and you gave me a letter that's not an x or a y, and so what do you want me to do with this random letter you just gave me? And that's what it's kind of saying with the button add slider k. And so what this actually means is it's saying, I don't know what k is, but if you want to just test different values for k, that's fine, I'll let you do that. And so I'm going to press the k here to add what we call a quote unquote slider. And the slider is going to basically change the value of k and show you how the graph results from this change in k. And so I can just slide it as the name suggests, and it moves my graph up and down. And if we're thinking about the context of this problem, we're looking for one intersection between our parabola and the line. So the problem tells us that k is going to be a positive constant. And so I'm not even going to try any values under 0 for k because I know it needs to be positive. I can see my parabola getting closer and closer until we reach right about here. And this looks like my intersection, so I'm going to zoom in here, and I can see the one dot, which tells us there's an intersection here, and there's not two dots, so there's not two intersections. And I'm going to click on this point, and I see that it is 2.25, 10, 1.25. And what the question is asking is it's saying k is a positive constant where these two things intersect once. What is k? And here I just found k is 9. And so I didn't have to understand any of the math here. All I needed to be able to do was graphically move my slider until it did what the question was asking, which in this case is one intersection between our parabola and the line. So I'm thinking k is 9 here. We go back to our problem, and k equals 9. Now let's move on to this next question. It gives us a function, and it says the function h is defined by h of x equals f of x plus 10. Okay, so let's work on this next example. It gives us a function f of x, and then tells us the function h is defined by h of x equals f of x plus 10. For which value of x does h of x reach its minimum? Now, mathematically, we could kind of try to put this transformation in the original equation, see what the resulting parabola is, but I think there's a much easier way to do this one graphically. So I'm going to start by just plugging in my original equation. Now, something I didn't mention before, I told you that Desmos only takes x's and y's, which is mostly true, but it also takes functions. And so I can actually put f of x exactly how the problem gives it to us, like here, and put equals, and then type in my function, 2x squared minus 16x plus 50, 2x squared minus 16x plus 50. And it's going to recognize that just like a y, so I'm allowed to use that f of x. Now, what I can also do, which is really powerful, is I can define h of x with this transformation, and it'll understand what I'm trying to do and show me that transformation. So, h of x equals f x plus 10, right? This is exactly how our problem told us it was defined. I just typed in what our problem told us. I didn't make any leaps. I didn't do any math. I'm just giving us exactly what the problem gave us. So, now I can see we have our two parabolas. We have the original one, f of x, and then we have the translated one, h of x. And what is this question asking? Well, it's asking when does h of x, what x value does h of x reach its minimum? So I know h of x is my black graph here, and I can look for the minimum. I can kind of scroll into this area, and if I click on where it looks like the minimum is, Desmos will populate another one of these points, telling me exactly what the minimum is. In this example, the minimum is -6, 18. We're looking for the x value, so -6 is what we're going to get here. As we can see, this is answer choice A, and that's going to be correct. So you could know that a plus 10 transformation inside your parentheses is going to shift your graph left 10 units, and you could have known how to find the minimum from the original equation, but We were able to do this one without knowing any of that, just by taking our two equations, plugging them into Desmos, and clicking on the minimum point. So hopefully this is kind of convincing you how incredibly powerful Desmos is, and how if you have graphs or any sort of transformation, Desmos is kind of a must use. Next, we're going to talk about circles. Now for circles, Desmos can help us with the center, with the radius, with distances, and with comparing forms. So here's going to be our first circle problem. I am going to put in this equation of the circle it gives us originally, just as they give it to us. And to understand the question first, it says that in the xy plane, the graph of the equation gives us an equation is a circle. Point P is on the circle and has coordinates 14, -2. If PQ is the diameter of the circle, what are the coordinates of point Q? Now, again, like I said, I'm just going to start by putting in the equation exactly how we know it. So, parentheses x minus 8 squared plus y plus 2 squared equals 36. Okay, so we have our circle here, and what it tells us is that point P has coordinates of 14, -2. So I can actually just put in these coordinates, and I'm going to do that just so I can kind of visualize where this is on my graph. So 14, -2, and I'm going to press label, and we can see exactly that 14, -2 looks like it's going to be kind of in the center here. So I can just kind of visually try to trace up from here and see what looks like the opposite side of this uh, graph. And kind of visually it looks like here. So I know we'll have to stay on -2 because this is diameter. And so it goes fully from one side of our circle all the way to the other. And so our y coordinate has to stay at -2. And so staying at -2, I get the point 2, -2. And that's actually just going to be our answer. And that's A. And the reason we knew that had to be the answer is first because it says it is a diameter here. And so we know our point goes fully through the circle from one side to the other. We have to stay on the same y coordinate, and we have 1 point. And so just by putting it in Desmos here, we could visually see 14, -2 is on this right side of the circle. We need the point directly on the left side, straight line over, so we keep the y coordinate the same. And we can just click here, and we can see it's 2, -2. So A is correct here. Lastly, we're going to look at some other graphs. Specifically, we're going to look at exponential, trig, some cubic, and then also Desmos can do some statistics, so keep that in mind as well. Starting with the cubic, we have function h is defined by this function, and the graph y equals h of x is in the xy plane and has x-intercepts at a0, b0, c0, where these are distinct constants, and it's asking us what a plus b plus c is going to be. So like we've done with our other questions, I'm going to start by just graphing this one exactly how they give it to us. So y equals, or h of x equals, in this problem, it's going to be the same difference, x minus 3, x plus 5, x minus 4. And x minus 4, x minus 3, x plus 5, x minus 4. Okay, so a, b, and c have this form where we have a comma 0. And so a comma 0 or any number comma 0 is going to be an x-intercept, or where our graph crosses the x-axis. So after we've graphed these, I can just click on our graph, and like we've done in other problems, we can see the x-intercepts here are just these little dots. So I can click them, -5, 3, and 4. So I'll go back here, and we'll say A is -5, B equals 3, and C equals 4. And which one I assigned to A, B, and C is a little bit arbitrary, but it doesn't matter because we're just adding them. So -5 plus 3 plus 4 That is going to equal 2. Now you could have just known that the factors for these were 3, -5, 4, and added them, and you didn't need to use Desmos on this one. So if that was the place your brain originally went and that's more familiar, totally great. Good way to solve this question. But if not, you can use Desmos as well. And it's a really simple way of doing the problem or checking it if you knew how to do it otherwise. So 2 is our answer here. Okay, here is going to be kind of an exponential decay one. So it tells us v of t represents the value of a car after t years. And it asks you, what is the value of this car after 4 years? Now, again, you could just plug this in and try to get the answer that way, but sometimes visualizing it helps. So I'm going to plug in the equation they gave us. Like I mentioned earlier, we can use function notation. So v of t equals 20,000 times 8.5 to the t. So the t, and this is going to give us our kind of exponential decay question. As we can see, it's going down very sharply until we're approaching 0. Okay, so what I can do on the second line is I can literally just put v of 4, looking for when our function v of t is going to be 4, so just plugging in 4 there. And Desmos is going to do this calculation for us right here, telling us the answer is 10,440.125. And so in this problem, v of 4 is what is the value of this car at time equals 4. We can just plug it in. Again, like the other problems, I didn't do any math on my own. I just plugged in what the question originally gave us, plugged in the value it's looking for, and got an answer of 10,440. And this is going to be answer choice B. So again, hopefully you can see just by plugging in what they give us, it makes this question so much easier. And the last one we're going to do is this kind of like statistics type problem. Now, Desmos has basically 4 functions of statistics that it can do. Not a lot of people know this, but you can type in something like mean and then put parentheses and put in numbers here to find the mean. You can also do ones like min and max. So like you can type in min, do parentheses, or max and do parentheses. And so these are kind of helpful to know. Now you could also do these in your calculator. You could know the formulas, but just having an extra tool in your toolbox is always going to be helpful in the SAT. So for this question, it's saying that the table shows the number of mystery novels sold at Brain Buff's bookstore across different months in 2023. What value of X such that the mean books is 120? Okay, so it gives us 4 of the values, but we don't know the fifth. And so what I'm going to do here is I'm going to set up this mean that I just showed you in Desmos. And I'm going to put in the values we know. So we know 95, 85, 145, 95, 85, 145. We don't know the X, but we also know 175. Now it's telling us the mean of these 4, but I need to find a value that's going to make the mean of all 5 of them 120. So starting with answer choice A, let's try 90. That gives us 118, not correct. Answer choice B, let's try 100. 100 here gives us 120, so B looks like our answer, but let's try the other two anyway. 105. Nope, that gives us 121. And then 95. That gives us 119. And so as we can see, B is our answer here, 100. Desmos can also be used for stats, so there are so many functions. Definitely take your time to understand them because it's going to be a huge asset on the SAT. So in summary, if you get stuck, graph. Graph everything on Desmos. Sometimes you can understand the question better by graphing it than you could by reading it. So graph everything you can, especially if you're stuck. Second, like I've mentioned a few times, practice using Desmos. You're not going to get good at it, and you're not going to get good at recognizing which questions can be done in Desmos unless you actually try it yourself. And so pay attention to which questions on our site have that little Desmos button and the answer explanation. And there'll definitely even be some that like we didn't make an explanation for, but you could use in Desmos. So try them on your own, see what works and see what doesn't work. And lastly, for those of you who are great at math, you don't need Desmos. That's not a good reason not to use it. Use it to verify your answers. I know students make silly mistakes all the time. So get your answer, take an extra second to check it in Desmos if you have the time, and that's going to help you a lot. So good luck on this and have fun using Desmos.